All right. Thank you, Dan. I actually lost your audio a few times, so I hope that isn't. Shivaji, did you lose Dan's audio at all?
Yeah, I did also.
Okay, so hopefully it's a problem specific to his connection, not mine. But people, somebody do this. If Shivaji, if you want to do this, if you have any trouble hearing me, but
sure.
Great. Okay, so I'm going to talk about psychology's replicability crisis. I'm going to give you sort of my little window on it, how I got involved in it. It's kind of different than the main lines of experiments that I've worked on that Dan was mentioning in attention memory. It's something I got curious about, and then it's sort of one thing led to another, and I found myself in the middle of a very controversial, kind of interesting, just kind of disturbing thing that has, from many directions, kind of almost swallowed up the field of psychology and become a huge concern and a source of all kinds of debate and some good new ideas, I think, in psychology. So it's sort of been it's been an unusual time, and I thought I'd just start by telling you kind of my little bit of involvement with it, so you get the concrete sense of what we were involved with. And then I want to talk more abstractly about some of the statistical issues and logical issues that arise when produce non-credible literatures in a lot of places, certainly a lot of places in psychology, but undoubtedly a lot of biomedical research in many other areas. So, okay. So let me, so I'm going to be telling you how my colleagues and I stumbled into this to start with. Some of you, I bet most of you probably don't have a clear sense of what this word priming means. It's a word that's become popular in psychology, and it really refers to the idea, which goes back at least a century, that you may be able to modulate people's behavior or mental functioning by very incidental exposure to meaningful stimuli. That is, stimuli that people wouldn't think they were paying much attention to, reading or seeking to comprehend, and just by flashing people, you might have a big effect on. Are you having trouble hearing me?
It seemed to break up for a bit. Am I the only? Kurt, would you agree with that?
Yes.
Oh. Okay, well, I'm not sure what we can do other than, it wasn't a total blackout, so maybe keep going and we'll see.
Yeah, okay. Well, I can stop the video, which can only help, right?
Well, Dan wasn't, okay, try it. I mean, it's kind of good to be able to see you.
Yeah.
Right.
Okay, let me continue, and if it's a persistent problem, I'll try turning the video off, but let's try not. Okay, so there is a universe of real experimentally replicable effects that go by the name of priming. And I'll give you a concrete example of how you might get one of them. If you simply read the word doctor, if we just put it in a list of words and you read that word, and then we come back a very short time, nurse, a semantically associated word, nurse, you will be able to read it more quickly by a variety of measures than you would have if you hadn't read the word doctor. And this effect has been frequently and easily replicated. It can even be done in classroom demonstrations, and its reality is not in doubt. But the topic of priming exploded in its interest and its popularity and its publicity around the year 2000, from about 1995 to 2005. And it seemed that the topic of priming the phenomenon of priming had become far more significant and interesting to the study of human behavior than just changes in the readability and the speed of reading words like nurse. And I'll just give you a few concrete examples of findings that were published that a lot of people refer to as behavioral or social priming effects based on this glancing minimal exposure to stimuli. So perhaps the most famous study of this kind was published by John Barge, now at Yale, with some co-authors, who said that if people were primed with words that have semantic associations with the elderly, like old, gray, and bingo, that the subject walks more slowly as they leave the lab. So it's almost as if they're miming or aping the actions of an elderly person. Kathleen Vose and her colleagues reported that having people read words related to money or look at a screensaver that showed pictures of money changed their behavior in the direction of being more kind of money grubbing and less generous and different and more self-reliant, and a variety of changes of different kinds. Brzezinski et al. Showed that at answering embarrassing questions, as if reading words like integrity and truthfulness actually inclines people to be a little more truthful and honest in their behavior on a questionnaire. So these effects kind of fascinated people and produced an explosion of interest. There were papers published in journals like Science reporting these results. There were one of the best sellers of all time, the book by Malcolm Gladwell called Blink, argued that these phenomena have tremendous implications for understanding behavior in daily life, in the business world, and so on. Nobel Prize winner Danny Kahneman wrote a book in which he said these effects were evidence for an important theory about the organization of cognitive processes. So these things had a sort of explosive impact.
Hal, I think we should try switching over.
So, sure, let me switch off my video if we're, okay. So, okay, so yeah, let me know if the problem is not resolved. So Kahneman actually said, was well aware of the fact that people find these results very counterintuitive. And he said to the reader of his book, the idea you should focus on is that disbelief is not an option. The results are not made up, nor are they statistical flukes. So basically, you do not believe these results apply to you because they correspond to nothing in your subjective experience, but that's sort of not an indication that they aren't real. So these effects interested a lot of people. And they interested my colleagues and I, and Doug Rohr and Christine Harris and I had a lot of discussions about these effects and kept scratching our heads in the feeling that there was something odd about these effects. It was clearly fascinating that priming could do these things, change people's behavior, but a gnawing doubt, like, does it really do those things? And when I try to figure out why we thought that, it's sort of two things I mentioned. The well-verified cognitive priming effects that I mentioned involving words, reading doctor speeds you up in reading nurse, only last a few seconds, whereas these social and behavioral effects last at least minutes, in almost every case, and sometimes weeks or months. So it seemed odd that the other effects would be so transitory and these effects would be so long lasting. It also seemed, I'm not going to go into it right now, but by several statistical measures, these behavioral social priming effects seem much stronger than the simpler and more obvious cognitive behavioral priming effects. So in a sense, it seemed like the results are almost too strong. So we just thought, well, there are so many published papers showing these effects. They must be true, but let's just take a look at it and see if we can confirm these for ourselves. We just want to see it here. We thought, we'll probably never publish this. Let's just get it going in the lab, just of interest. So we started with one that seemed particularly simple and convenient, a study by John from the John Bartsch lab called, often referred to as achievement goal priming. And the idea is that if you have people look at a display composed of words related to achievement, like strive, attain, and win, people are randomized to either those kinds of words or neutral words like building, staple, green. Then in a subsequent task, they're given some demanding, tricky puzzles to solve, which are themselves neutral and don't have any relation to the theme of achievement. And the finding was significantly better performance for people in the achievement priming condition. So the idea is mere glancing exposure to words associated with competition, attainment, and striving is evidently producing a little bit of more. It's juicing up the motivational systems for attainment, competing, and striving, and producing a measurable impact on behavior. So we said, let's just do this experiment in our lab exactly the way the original study was done, and that's what we attempted. These are the results of the original study on the left and our data on the right. There's no error bars because CARD didn't provide enough data to compute error bars, but you can see that there was a marked increase in performance on the puzzle task for people who were randomly assigned to read words related to achievement compared to the other group. And our results, however, were much more disappointing. No difference, no statistically significant difference, trend in the wrong direction, so not even a hair of an effect there. So we got in touch with John Bard, and he was kind enough to offer a suggestion. He said, I always get stronger effect if I wait 5 minutes. And he said there was one published study that suggested maybe there is a stronger effect after you wait 5 minutes. So we thought, okay, let's do it all over again, and let's wait 5 minutes. So we did that, and this is the result. This time it was again blotto, but no trends of any kind. So we thought, all right, well, this is getting odd. Let's try a different one. Let's try the most famous one. Let's try the elderly walking study. And this was either related to the elderly or not related to the elderly. And people who were primed with words that were elderly related were said to leave the lab more slowly, even though they didn't even know that their walking rate was being assessed. So two things struck us about this study beyond just its interest value. Well, oh yeah, let me just mention the BBC actually came and did a quote replication of the study in their program, which was pretty popular science program, and it's been cited 4,700 times. We had two issues with the original study. One was it wasn't clear if the experimenter knew what condition the subject was in, and clearly to have optimal control, you don't want the experimenter to know what condition the subject was in. The experimenter's measurement of walking time was done with a stopwatch, and that seemed kind of fallible too. And there were also just 30 subjects. So we thought, well, let's do a direct replication, but let's improve the measurement. Let's use more subjects. And so we got these nice millisecond timers that are used for timing of athletic competitions. And the biggest challenge in setting up this experiment was actually making sure that concealing these in our lab, which was actually rather tricky. But we got an objective measure of people's time leaving the lab. We replicated the experiment exactly to the best of our ability. And here was our result. With 66 subjects, we found no significant difference. The trend was actually in the direction of faster walking for elderly, not slower. So it was again in the wrong condition. We said, okay, well, in for a penny, in for a pound. Let's try another one of these things. We tried an experiment I always thought was hilariously funny, sometimes referred to as rudeness priming. And in a rudeness priming study, people read words that are related to the idea of rudeness, like bother, disturb, intrude, and so forth. People are randomized to either those words or neutral words. And then at a certain point, the computer tells them, please go and get the experimenter. And so they say, okay, I need to go get the experimenter. They walk into the next room, they find the experimenter, and they find the experimenter, but the problem is the experimenter is talking to someone else. So the outcome measure in this experiment is how many seconds does it take them to interrupt the person. So at a certain point, it's clear this experimenter is never going to turn to them, so they have to just barge in and interrupt them. And the question is, how long does it take? They found that priming people with these words made them interrupt after a shorter period of time. And we ended up finding no difference whatever. However, UCSD students are simply so polite, they're slightly unsuitable subjects for rudeness research because the total rate of interruption was noticeably and incredibly lower. we tried one more of these things, a paper published in Psychological Science from the same lab that looked at spatial distance cues. I'm not going to walk you through it, but I'll just tell you we got the same pattern of results. So at this point, we were really, really scratching our head. We were thinking like, these are some of the most famous results in recent psychology. They're sort of widely assumed to be right. Why yet we're just striking out and trying to replicate these. And then strange rumors started floating in from the community that we're part of, which is the cognitive psychology community. We found that 3 other cognitive labs were pursuing almost identical programs of replication due to very similar doubts. And those people were, all of these colleagues in this field had basically said, these effects seem just interesting, very interesting. I just want to see them for myself. And every one of them was also finding nothing. This was one example that was very similar to the achievement goal priming studies by App Dijksterhuis, in which people were primed with words related to professors or soccer hooligans who they perceived as sort of the polar opposite end of the continuum of sobriety and information processing. And the finding was that basically people did better on the cognitive task after they'd been stimulated, primed with words related to professor rather than soccer hooligan. My colleague David Shanks at University College London also just thought, I want to try this thing. I want to see this myself. So he tried it. He tried 9 experiments. Every one of them basically failed to produce this effect. This is David Shanks' paper in which he titles it an elusive phenomenon. I think that's a charitable way to sum up what he found and how he felt about it. Meanwhile, some cognitive psychologists in Belgium, Stefan Doyen on the left and Axel Clearmans, said they wanted to see this elderly walking study for themselves. So they did that one again and didn't find a thing. This started to produce an uproar because these effects are pretty well known. But at a certain point, though, we started to get some pushback as we began seeking to publish these results and talking to people. And I think I would sum it up that people said, well, there's a sort of tribal difference within the psychology community. And maybe these cognitive psychologists don't really know how to do these social priming studies. They may lack artistry. That was Danny Kahneman's word. Maybe they don't even want these studies to work. That was the funniest one. So maybe we had sort of spooked the effect out of existence. And who knows? It's not a crazy idea. But we did have some responses to this. I mean, we had in every case, we and the other research labs having the same problems had followed published method sections with actually, if anything, extra precautions against things like the experimenter knowing what the subject was up to. As for what we wanted, our research assistants, we never met the subjects. Our research assistants who interacted with the subjects not only did they know what we wanted, they didn't even know what we were measuring. So that they didn't know that we were measuring particular things, the features of the product. So it seemed very improbable that our skepticism was spooking the effect out of existence. And then finally, if you look at the sort of theoretical analysis in the field about why this priming effects might work, they involve very simple ideas that would depend only on activation of concepts. There's this generally accepted idea that meaningful stimuli triggered something equivalent to detectors in the brain, which are then active for some period of time. This only involves reading. It shouldn't involve any artistry. So why should that be relevant? But we thought, okay, well, again, in for a penny, in for a pound. Why don't we start looking at priming results that can be priming studies that could be done online in order to maximize the comparability and to take all the artistry and bias out. So we're just writing PHP scripts that run these studies, and the person is only having the communication through these scripts. And then there's no ambiguity about what is actually going on. So one example of a study we looked at, there was a study that's found, I already mentioned it a few minutes ago, if people are exposed to words that are related to honesty, are more willing to disclose problematic or embarrassing behaviors like problem drinking. And here's of the original study and our 2 replications. On the left, this is the number of admissions of problematic drinking behavior made by people in the honesty prime group and the neutral group. And on the middle and right are our findings. So you see, with larger samples, we found no effects. Again, a great big 0. We did 2 more experiments just to, with some methods improvements, nothing. So you're starting to get the picture. There were some studies that showed that exposing people to pictures of money made them shifted their attitudes in a sort of more right-wing or pro-nationalistic direction. Here are 4 studies and our replications. You see on the left, every study has a black bar above the gray bar, a difference, statistically significant difference. We got nothing. So this is a summary of all of our results. At one point, we made other meta-analytic syntheses of all our results, and it's stunning how close the mean standardized effect size, which is like the difference between groups divided by the pooled standard deviation. It's stunning how close that is to 0. I mean, it's like people have said, you know, are there any psychological effects that are really nothing when you measure them properly? And this one's like, wow, this one seems pretty close. If you include all the other groups that I mentioned, you also get a mean standardized effect size very close to 0. Okay. So it's still possible to wonder at this point, well, but you know, maybe you guys were still incompetent and there was something that the original investigators knew that they haven't been able to articulate in their method section that you didn't do right. And at that point, though, some very large, much bigger studies than ours began to roll in. And I'll just show you a few of them. There's a study published in the Journal of Experimental Psychology called the Many Labs Project in 2014 that had 36 data. At this point, lots of groups were consortia were forming to different psychological effects. And the first of the big consortium studies had 36 labs working parallel, and they had 2 social priming studies. If you look down on the x-axis here, again, is Cohen's d, the standardized mean difference. And every one of these dots is a study, and the dot with a with a black circle around it is the mean across studies. So you see, these are again stunningly close to 0.0. So these Lansing stimuli are indeed having no detectable effects. And you see there is heterogeneity across labs. There's some variation there, but that's statistically no greater than you would expect just based on sampling error. So it really looks like the truth is a 0. It's not that there are different effects in different labs. It's just that there's sampling error everywhere. So the results aren't exactly the same in every lab, but the true effect, the true mean effect size is really stunningly close to 0. Okay. And then there was a lotto. So I just give you some examples. So I think at this point, there are still people who will argue with you about this, but there's no serious defense that I see for the idea that these effects are real. There's interesting debate about the scope of the effect, like what exactly is the range of effects that don't exist, but there's no serious debate about what the data show. But what there is a tremendous, for us, we were left puzzled and reeling by this, as I think a lot of people were. How is it possible for so many studies of simple randomized experimental manipulations to get statistically significant results and yet be completely unreproducible? I mean, it sort of erodes the foundation and the credibility of the whole field if such a thing can happen. You got to ask, well, how did it happen? And what is the scope of it? And how do you know that it isn't happening with some new topic that you may be interested in? And that's what I want to talk about for the rest of this talk, and I'll do so nicely. So let me say the first thing Oh yeah, actually, when I first got interested in this, my attention was drawn to a paper by a physicist and chemist who some of you may be familiar with, named Irving Langmuir. And Langmuir has a classic paper called Pathological Science in 1953, in which he was, I think, inspired by N waves and polywater. He was before cold fusion, of course. But he tried to lay out some criteria one could use this to alert you to the possibility that an effect is not to be relied upon. And it's interesting. I found this really interesting to look at. One of the first one that he lists here is the magnitude of the effect is substantially independent of the intensity of the causative agent. That was very clearly true, and that fits the priming one quite well. So it is true that, for example, the suggestion that an effect would show up 5 minutes later, but not immediately, which is opposite to all prior experience with replicable forms of priming, is kind of fits with that idea. And there are other findings that might fit with it. Certainly the fifth criterion that Langmuir listed, that criticisms are met by ad hoc excuses thought up on the spur of the moment, is highly accurate. The others, though, maybe not so much, like claims of great accuracy. I don't think in the problems in psychology that I'm familiar with, I'm not sure that the authors of work that proves unreplicable have made claims of great accuracy. They've made firm claims of statistically significant differences, but not of great accuracy. But anyway, it's interesting. There's at least some overlap between the indicia of non-credibility suggested by Langmuir and what's seen in current present-day psychology issues. But let me step back and tell you what I think is going on here. And I just make it really simple. And I can't prove to you what's going on, but I'm going to give you an argument about what I think is really going on. So there's a couple of crucial ingredients. And crucial ingredient number one is a feature of many areas of science, not just experimental psychology. It certainly includes biomedical research of a lot of types, and really very widespread. And that is publication bias. And what I mean by publication bias is journals are eager to publish an effect that shows a statistically significant difference in some outcome variable, and often ascertained with null hypothesis statistical testing at p less than 0.05. That is, now there are lots of exceptions. If you search papers, you find non-significant results published, but if you look at them, usually there have been some big meta-analyses looking at this. Usually when people say, oh, it's not that bad, what they mean is that the result that there is some results that are published that are not significant at p less than 0.05. But if you look, you usually find those are not the results that got the thing published. So those are secondary, subsidiary analyses that contain non-significant results. But there's usually at least one or more key statistically significant difference in an outcome variable. So what does that mean? What that means is that reality is statistically noisy and journals are truncating on an outcome variable. So they're doing bias sampling. So therefore they are not going to reflect reality. It's really that simple. So if you say, well, how can anybody, this has been obvious to statisticians for a long time, how can this not be well digested in the research community of so many fields? I think one answer is because they're tripped up by Fisherian statistics. They think that this null hypothesis statistical testing provides a firm upper bound on the rate at which this kind of error can occur. And if you talk to science, the problem is improving now with the replicability crisis, but you could get on any campus, you could find hundreds of professors who would agree with you with this statement that our alpha level, 0.05, provides a ceiling on the rate at which we allow errors to creep into our literature. And then they think 5%, that's not so bad, right? I mean, that's not so bad. But of course, the data I was showing you from our concrete it's not 5%, it's working. So what's up with that? Well, it's simply not true. The alpha level does not provide an upper bound. The math doesn't work that way. What you're interested in, if you're going to only publish significant results, is what's called the positive predictive value, which is the conditional probability that a result is real, given that it is significant. And that number can easily deviate, can be way lower than 95%, even when the alpha level is 0.05. It depends, as probably a lot of you know, on power and two quantities, power and prior probability of an effect. So if you take some guesses at what those might be, it's very easy to end up with 30 or 50% being, of 30 or 50% of positive results being false positives. This is another way to represent it. This is a graph of positive predictive value as a function of power and prior odds. And again, you see it. It's very easy to get numbers like 30, 50, 70%. This is papers published in Biostatistics in the last 30 years, which is John Ioannidis' paper, Why Most Published Research Findings Are False. And this paper, it's now cited enormously often, but after it was published, it kind of freaked people out. In the scientific fields I'm familiar with, people were like, what is he talking about? I mean, that better not be true in my field. It's like, what he was doing was just a little Bayesian math to say, look, it's quite realistic to think, just based on publication bias, low power, and low prior probability of effects, that you can have a literature that is mostly publishing things that aren't true. And I remember when I first read it, it was like, people were, as I say, kind of freaked by it. I think they're starting to get the picture now, but they're a little bit freaked out by it. But I want to draw your attention to something less well known, which I think has played a huge role in psychology. And that is the rarity of direct replications. Because if people would do direct replications and publish them, then a lot of these weeds would get pulled out automatically, right? That would be the self-correcting virtue of science that everybody talks about, but doesn't always see happening. But when you talk to people in many fields, including, I think, the most afflicted, the fields that have the biggest credibility problems, and you ask them, well, do you all do replications? They say there was an article in 2012 in Science that interviewed social psychologist Norbert Schwartz of then University of Michigan, Ann Arbor, and he said, he was very candid, and I think he said exactly what was the honest truth. He said, direct replications may be rare, but what we do is conceptual replications in which we change a bunch of stuff, and then we see if we still get the result. And he said, this is really better than direct replication. Because he said, these are highly valued because they look at the stability of a phenomenon across different content domains. So in the jargon of psychology, they validate the measures. They provide better support because they're showing that the effect is robust, that it is not limited to some narrow set of circumstances. Christine Harris and I pointed out in a paper around that time that the dangerousness of thinking that a direct replication is a substitute for a conceptual, or sorry, that a conceptual replication is an adequate substitute for a direct replication is seen by thinking of a little flow chart, which is just what somebody does one of these replications and it either works or doesn't work. What happens next? And let me show you, I can't prove to you this, but I have never had anybody seriously debate this point. If you do a direct replication and it works, you're excited. You think, well, we know how to do this thing. It's real, that's great. It would be very unlikely, probably even now, that you could publish that result. But you'd tell everyone about it and you'd feel good about it. On the other hand, suppose you do a direct replication and you get a failure. You duplicate everything the original investigator did and it doesn't work. The first thing that happens is you lose faith, either in yourself or in the effect, but your assessment of the credibility of the effect takes a big hit. You might publish it. Clearly, its publication bias means you probably can't publish it, and that used to be the case. That's changing in psychology. I think it's changing in a lot of fields, but still, at least you would tell people about it. We did exactly what Fred did, and we didn't get an effect. You know, there's something up with that. That's certainly what we did when we started doing the direct replications. Even though we were aware that this was culturally unusual to be doing direct replications. But let's think of what Norbert Schwartz is saying is a better substitute. It'll work better for us, and that's doing a conceptual replication. So that means you change you change the intervention a little bit, you change the outcome measures, you change it up a little bit. So what happens when you do it and it works? Well, the answer is not only are you happy, but you can publish it immediately. You have the ideal situation for publishing it. Why is that? Well, because if you publish it, if you submit it to a journal, it will be sent to the original authors for review, and you can be sure they will like it very much. So you will have tailwinds rather than a headwind in publishing a successful conceptual replication. So a high proportion of these will find their way straight into the literature. What happens if you do a conceptual replication instead of a direct replication and it fails? Well, you think, geez, I shouldn't have changed some, I changed like 6 things, and maybe I shouldn't have done that. I shouldn't have changed so much. But what does not happen is that you lose faith in the original result. What it questions in your own mind is your decision to make such extensive changes in the original result. And as I said, I have talked to people in a lot about this in psychology and biomedical research, and I think people agree to the point where many people will say, well, that's why I tell my graduate students never do direct replication, but always do conceptual ones, because they're so easy to publish when they work that it's kind of well known. So what's the implication? Why is this important? Why am I telling you about this? Well, because any field in which people do no direct replications and many conceptual replications, particularly if they're underpowered, will automatically spawn large literatures in which non-existent effects appear to enjoy diverse empirical support. So what this means is the file drawer effect of failed attempts is not only invisible to outsiders, it doesn't even shake the internal faith of the investigators themselves. And I think that's what's really, I think the pathological science that we see in so often now in psychology, where you have a mountain of always different studies, no one using exactly the same method as another, but all of them appearing to support the same conclusion. And yet you come along and try one of them and you won't get it again. It won't work. That combination is exactly what you get when you have everybody says do conceptual, not direct replications, and the results can be easily published in the literature when they work. They vanish without a trace when they don't work. So this is really what I'm saying. It's like an insidious interaction between publication bias and the cultural practice in a science of doing conceptual rather than, and it takes both to create a problem. So just an aside here, but people I know in the field of ethology, animal behavior, say that nobody ever does direct replications in ethology. But what they do is they'll move it to a new species. You found something in prairie voles, I'll check it out in Siberian voles. But the difference is they will publish it even if it didn't work, because they think, well, that's interesting. It doesn't work in Siberian voles, but it does work in prairie voles. And soon the literature will tell you, is this thing really important or not? So it would be fine to do conceptual replications if you publish them all. But if you're only going to publish the ones that work, you're dead. Your literature will become a garbage heap in which you can't tell the garbage from the real stuff. Now, I'm embarrassed and sad to say that there's something else I have to mention that makes it all even worse, which is really depressing and really embarrassing and pretty close to fraud, and in some cases, and that is the existence of something called p-hacking. There's a great paper published in 2011 by Simmons, Nelson, and Simonson, which coined the word p-hacking. I imagine many of you have probably heard, maybe, I don't know, in physics, maybe you don't have to think about p-hacking, but it's sobering to know that everyone in biology now knows what this word means. So they obviously know it because they've seen it. And what it refers to is dredging a data set, trying a variety of different analytic choices with an intent to get some significant result. And some of these are things that I think all of us have done a little of and sort of knew this isn't great, but like analyzing data after every new subject is run. That's something that's, I think, one of the more benign forms of p-hacking. Then there are things that shade right over into fraud, like throwing out outliers, knowing that they don't favor your hypothesis. Suppose you run 40 people and you say, well, 3 of them, I could throw these out. But you're doing it with the knowledge that that's going to favor some hypothesis. What was basically before this paper was published, everyone knew these things, you shouldn't really be doing them. Some of them shaded over into fraud, some of them seemed quite benign, and sort of minor statistical peccadillos. But what this paper showed is, you just start doing a few of these and your statistics become garbage, because the conditional probability of a significant effect given 0 real effect, which is supposed to be what the alpha level is putting a cap on, just is blown right through. You can easily get more than 50% false alarm rate when the null hypothesis is true, if you just do like 2 or 3 of those things at once. It's a very compelling paper just doing these simulations that shows a huge effect in psychology. People realize, wow, we really got to do something about it. And it has produced the growth of pre-registration. As many of you probably know, pre-registration emerged in drug testing. It's required in the FDA's 3 set of phases of study to try an investigational drug, that you check, that you specify in advance all your analytic choices. And there are now tools on the web to allow people in every form of research to pre-register their results. And this has become quite popular. I haven't seen any numbers, but it's clearly a non-trivial fraction of new papers in experimental psychology are reporting pre-registration. It's not a majority, but it's not a trivial amount. So that's a really good thing. But that interacts with everything we were talking about before. Publication bias becomes all the worse if you have people. It really means the alpha level is bogus if you have people p-hacking. So you put all these things together, and it's not surprising that, sadly, after a lot of work on experimental psychology, we really have a lot of train wrecks to sort out. And this is just a list of some of the famous, moderately or very famous effects in psychology that have been debunked since 2010 to my satisfaction. People might debate some of these, but I think they're all in pretty bad shape. There's a number of new results that I think look equal. This is very definitely a partial list, not a complete list. So let me just sum up by saying, I'm a little in overtime, but let me just sum up by saying, how can you tell if a finding is credible? So there has been hope for some. So first of all, I hope I persuaded you that looking for what used to get called convergent validation, which really means lots of related findings using non-overlapping methods, is not only is it not satisfactory, it's just an invitation to wholesale importation of false positives into your literature. People with statistical background have often hoped that maybe publication bias, even though you knew it was happening, could be corrected for. And there's a bunch of attempted techniques, statistical techniques, for taking taking the statistics of an entire literature and trying to get around publication bias and looking for indicators of it in funnel plots, correcting for them in various ways. But what seem like the best simulations and analytic work that I've seen in this topic suggest they just don't work. They're very sensitive to the quality of the studies that are going on. Even a little bit of fraud wrecks them, and they are just not likely. So the problems of publication bias together with p-hacking contaminate a literature in a way that can't be inverted. That function cannot be inverted and corrected for. The thing that might work, if only you could use it, is that some subfields actually do publish null results. So I mentioned the example of ethology, where they'll publish new study with a different species is considered highly publishable, whether it works or not. I think in behavioral genetics, twin studies, negative results are really interesting. Everybody's fascinated with them. They will publish them. But it's a very highly heterogeneous set. So as an outsider trying to look at the literature of behavioral science and say, can I believe this? There's not much use to you because you're not at the bar at the meeting to talk to people about whether they publish things that didn't work or not. I think, unfortunately, in many areas of behavioral and biomedical science, publication of null results is still, even right now, rather rare. It's publication of pre-registered replications is becoming more common, but just publishing a null result that wasn't a replication, pretty unlikely. So you got publication bias. So there's no good way for outsiders to know what they can believe. The conservative strategy, if you think about it, is to believe only results that have been confirmed in a pre-registered, explicitly confirmatory, and large and well-powered study. So what I mean by explicitly confirmatory means that you have reason to believe the people that did the study set out intending to test something and report the results either way, which they can probably do now, but couldn't have done 10 or 20 years ago. And I think those studies are becoming more common. But you need to ask for those studies if you're going to base policy changes or any kind of major decisions on results. You are, for me, these things are stunning and unexpected. I just assumed you could believe what you read in the literature, but I, like many people in my field, have come to think you really can't believe it unless you have a very exacting condition met, which is what I've described, what I put here as the conservative strategy. J.P. de Ruyter and I have argued in the APS Observer that our field would be wise to embrace this and to recoup our reputation by embracing two principles of maximum accountability, which is that we should just go with truth and labeling. Just stop saying that anything is shown to be the case by one or even many similar empirical results in the literature. That's not a high enough standard. You can't believe those things. What you need to insist on is multiple pre-registered direct replications. And everything else should just be labeled in textbooks and reviews as tentative. If we did this, we'd get a reputation for being a highly reliable field rather than a highly unreliable field. But I see no sign that we're persuading everyone. People say, well, you want us to go, and there's all kinds of things we're sure of. There's something called the Stroop effect that some of you might have heard of. They say, you want us to pre-register the Stroop effect? We say, sure, there's no big harm in that. And if it results in a literature in which people can believe what they read in the textbooks, we don't have any other path to get there. So we really need to do that. I think it's interesting that this idea is actually quite close to what the father of null hypothesis statistical testing told us. If you look at what he said about p less than 0.05, it's pretty interesting what he said. He said it's usual and convenient for experimenters to take 5% as the standard level of significance. In the sense, they're prepared to ignore all results which fail to reach the standard and to eliminate them from further discussion. But he says that what counts as experimentally demonstrable is when we know how to conduct an experiment that will rarely fail to give us a statistically significant result, which is really much closer to the standard of large pre-registered study than any textbook writer or review writer is currently believing. Okay. We also think it would be useful if we could recreate what I think was an ethos of psychology many years ago, which was that when people's results are not replicated, they should normally be expected to do their best to reproduce their findings. In most of the cases I talked to you about, the original investigators did not seek to reproduce their results. They just let the topic go. Okay, well, thank you for your attention.